I'm Stefan, this is Fabian. We're from a software company called Rubicon, located in Vienna, Austria. And just to make it clear, we're not affiliated with Ruby in any sense. We get it asked a lot. The name is purely coincidental. In fact, we're heavy users of C#. And one of the things we're doing with C# is we're developing, oh, this is better, right? We're developing a product called Actanova, which is aimed at the public sector. In fact, it's a kind of document management, sorry, document management, compliance, and workflow. Well, for any kind of public sector organization, at least in our part of the world. And we have a lot of different customers, like the national government, state governments, and even municipalities, like this one, which is an actual town in Austria. I think their #1 business process is ordering replacements for their town signs, because for some reasons they get stolen a lot. Anyway, so there's different levels of sorry, different levels of administration, and it's not Austria alone. It's even Germany and Switzerland, and you know they share some of our requirements. But they add some others. They have some of their own all the time. And to make things worse, every single customer might have their own requirements or their own IT infrastructure to integrate with. So the question is, how can we actually handle this? Well, we could kind of put every feature in the product that we can possibly think of and try to configure it on and off. Or we can try to provide some scripting or user exits or events or whatever. But, you know, it might get a mess if it's too much of it.
When I built that system.
Oh, I don't know. I just did some Google image search for...
Are the CLR guys?
Well, it might be the famous Hex for Charlie from some host system. I've seen a slide. It's cool. That look quite like this, but I'm not sure. So anyway, what we're looking for is some way to modularize these features for different kinds of organizations, for different kinds of customers. So just to make clear where we are coming from, we like to develop our applications using domain-driven design and the sense that Eric Evans established, which basically means that we have an object-oriented class for every business entity. And of course, we're developing our features based on use cases or stories or what have you. And so what we're doing, when we're implementing a use case is, well, we're basically just touching every class that's affected by it, maybe adding some. And this definitely is a challenge to modularization. Ivar Jakobsen actually wrote a book about it. It's called Aspect-Oriented Software Development of Use Cases. It's a quite elaborate book. And what he's doing is he's recommending to just basically start from an empty or basic, very basic object model that doesn't contain any features, and then just add the features to it, and you will have to separate two dimensions here. One is the object model, the classes that you have, and the other dimension is the use cases. And for every use case that you want to implement, you just add the bit that affects each class that needs to implement this feature. And you just do this for every use case, and finally have some magic applied and get your object model built for you. And if you're talking about products like Actanova, we really want to have product lines where we can mix and merge and pick features and add them and have their logic applied to our classes and maybe remove them and build all kinds of combinations with it. So just editing the source code of each class is another question, of course. What ways do we have to change a class or to add functionality to it? Well, subclassing comes to mind, of course, and has two real advantages. It's very simple. Everybody can do it. Everybody has learned how to do it. Everybody has done it 1,000 times, and at least in the .NET world, you have a very well-defined extensibility. Like if you don't have the virtual keyword on a method, nobody can override it, and you're safe in future versions. Problem is, if you do that for a lot of use cases, you end up with a lot of separate subclasses. And well, how do you bring them together to a single product? Of course, one way would be to have multiple inheritance, but the bad news is that we don't have it, and the good news is that we might not want it because it brings its own set of problems like diamond inheritance. Another way would be to kind of linearize the use cases into classes, but it adds a lot of dependencies that have no real reasoning behind them, and you can't just remove a feature without modifying the layer under it. So yeah, another problem would be if you have an existing class hierarchy, how would you apply your subclass to existing subclasses? If you subclass A, and we want the same behavior in every subclass of A that exists, we would have to just kind of implement it over and over and over again. So clearly, we can really handle this with inheritance. Yeah, just to be complete. Ivar Jakobsen used aspect-oriented programming. He did a lot of samples in aspect-J in his book, but it's not where we're going. We try to stay in the realm of object-oriented programming. And yeah, one obvious solution would be to use composition instead of inheritance, like we've all learned it. But at a certain level of complexity, that gets pretty tedious too, because if you look at it, if you assemble a lot of features to a single class, you have to do a lot of delegation. And if, like in our example, we can't really touch this class A, we would have to derive from it and do this delegation in a subclass. And now we can't really remove a single feature without editing this derived class, which is not as bad as is with inheritance only, but it's still a lot of work to do. Yeah, and again, if we have existing subclasses, we would have to do it over and over again. And additional problems would be that if you have dependencies between features and use cases, it's hard to handle. We could have parallel class hierarchies between our static class model and the modifications that we're trying to apply to them. But even without this, in some cases, we just have too many dimensions to handle here. So it doesn't work out too well, unless we have some way to get this composition applied automatically to our objects, and that's exactly what we were trying with remotion Mixins. And yeah, Fabian is going to tell you about them because I really don't know anything.
Okay,
you get it on.
Can you hear me? Okay, it's better? Yeah. Good. remotion Mixins is a Mixin library for static .NET programming languages. Some of you, or most of you, probably know Mixins from dynamic programming languages like Python, Ruby, Perl, or from C++ template programming, or maybe from Newspeak, which we heard about today. But even those who don't probably know Mixins from their local fast food stores, because Mixin programming is actually the McFlurry style of programming. The McFlurry principle works as follows. You take some basic flavor, you mix in some additional stuff, and you get the finished product, right? Mixin programming is quite the same. You start with a basic object model, you mix in additional stuff, and you get your extended object model, which is your finished product. With remotion Mixins, you can add stuff to your classes, and you can modify the behavior of your classes. And what I'm talking about now is how to use them. How can you write Mixins using remotion Mixins? Well, to create a Mixin, you just start with a class, the Mixin class. You decide what features you want to add to the target classes of your Mixin, and you implement those features as interfaces on your Mixin class. You decide what behavior you want to change on your target classes, and you implement them as overrides, as member overrides on your Mixin class. That's actually quite similar to declaring subclasses, ordinary C#, but since C# doesn't provide any support for Mixins, we have to use some different means of creating overrides, member overrides, as we'll see in a minute. Okay, once you've created your mixin, you decide what classes should be extended by your mixin, and you configure them declaratively via custom attributes applied to your mixin class, naming the target class influenced by the mixin, or you use XML configuration, or you use imperative configuration at runtime by adding specific mixins to specific classes with statements. You can also turn it around. If you don't want mixins to name their target classes, you can also have classes name the mixins they want to include or use, which is actually done, using a different attribute now applied to the target class, which names its mixins. This uses relationship is similar to how multiple inheritance works, because the class can say it wants to inherit features both from mixin A and mixin B. So the question is, does it also suffer from the same problems as multiple inheritance does? And the answer is no, it doesn't, because you don't really have inheritance, but you have automated composition, as Stefan said before. Because remotion Mixins derives a generated class at runtime from your class, and this generated class aggregates mixin instances. It implements the interfaces added by mixins. It overrides the members, declares to be overridden by mixins, and it delegates the respective calls to the respective mixin instances. We create this generated class using reflection.emit, which is why you need to use an object factory to create instances of your mixed classes. A complete mixin configuration with your classes and your mixins constitutes your product. If you want to create different products or different variants of one product, you just use different mixin configurations. You can create assembly components, packaging related mixins, and decide at deployment time what features your product should include by just deploying the respective assemblies together with your class model. Okay. So we used the remotion Mixins library quite a lot at Rubicon, or we have been using it quite a lot, actually, and have found out that although it was originally meant for product line development, the library is actually quite a nice tool to have in general programmer's toolbox for modularization and extension code reuse. And because we don't really have the time to do a fully featured product line development demo, I'll just do a demo with two very simple mixins, just to show you how it looks in code if you want to extend classes using mixins. I've prepared a solution with a few different projects. And it includes a domain model, which is very simple, just consisting of two classes, an order class and a person class. The person class simply has a few members and a constructor initializing these members, and an overridden toString method, which just returns a formatted representation of the class members. The order class looks exactly the same. It also has a few members, a constructor, and a toString method, and the toString method simply returns a formatted string. Okay, and using mixins, I'll do two things. I'll add an implementation of the iClonable interface to my domain classes. I'll implement the cloning algorithm once and have it applied to both classes. And I'll add localization to the person class's toString method. Okay, so I've also written a test driver, which is quite simple actually. It just instantiates a person instance, prints it to the screen, string representation to the screen, checks whether it's clonable. It instantiates an order, prints it to the screen, and checks whether it's clonable. At the beginning, both classes are not clonable, and the toString method seems to work, but it's definitely in US date format, not localized in any way, or just default in the default way. Okay, now I'll create the clonable mixin. Okay, to create a mixin using remotion Mixins, you start by creating a mixin class. I'll name it clonable mixin. I derive it from a base class provided by the remotion Mixins framework, which provides certain services to my mixin. I don't have to derive, but in this case I want to, because I want to use the services provided. I specify what requirements I have for my target classes. I don't have any requirements besides them being objects. And I add the interfaces I wanted to add to my target objects. Okay, I'll implement cloning using a trick you probably know. I'll use serialization to make a deep clone of my target object. I'll just use a helper class. Which simply serializes an object to a memory stream and deserializes it again from the memory stream. That's not a very good algorithm, and but it's a default implementation of the cloning of the clonable interface, and I'll just add it this way. So, okay, the object I want to clone is actually the target object of the mixin, and the target object can be accessed via this property, which is added by the mixin base class, which is why I derived my mixin from the mixin base class. Okay, then I'll go to my domain classes, which should support cloning, and just tell them that they should use the clonable mixin. Same for the person class. Rebuild. Okay, and now if I execute it, the test driver should detect that really both of my objects now implement the iClonable interface, and cloning works, of course, using this serialization trick. The data of the cloned object is the same as of the original object. So why does this work? This works because my test driver instantiates the objects using the object factory provided by the Mixins framework, both for person and for order. If these objects were instantiated using new, we couldn't intercept that, but because we are using the factory, all mixins applied to these classes are included. Okay, this was the first feature, adding new behavior by adding interface implementations via mixins. Second feature is overriding members, and I'll do that by applying localization, because Arnold Schwarzenegger was actually born in Austria, so he might prefer his birthday to be printed in German with German culture information, so you can actually read it. So I'll create a mixin for that. Start with the mixin class. It's again derived from the mixin base class, but this time I don't implement any interfaces, but instead I'll add an override. I override the method toString, and as I said before, I can't use the C# override keyword because C# doesn't offer any mixin support, but instead I use an annotation for that and a custom attribute. Okay, what does this method do? That's a bit more code. It's a bit longer, but it's quite simple actually. It just sets the current culture of the current thread to the Austrian-German culture, the German language Austrian locale, I think. Then it calls the overridden base implementation of the toString method. The base property is again one of the services provided by the mixin base class. And then after calling it, it restores the culture of the current thread as it was before. Okay, this time I'll not use a uses attribute, but I will change the person class from the outside transparently. So I'll just add an extends attribute to the mixin. So the person class stays completely the same as it was before. And now if I execute this, it won't work. Why doesn't it work? clearly it's still US date format, right? It doesn't work because in my solution I have different projects, and my mixin is actually built in a separate assembly, and I have not deployed this assembly to my application. And I'll do that now by adding a reference. And execute again. And wow, it's a German date now. Okay, so these are illustrations of the two main features of the Mixins library. You can add implementation using interfaces, and you can override members. And at the same time, it was illustration of the two configuration possibilities. You can include Mixins from the target class, or you can extend the target class transparently from the outside. So much for the demo. Beg your pardon?
Are you going to talk at all about how it works under the covers?
No. If you want to know. if you want to know.
The guy in the back row I happen to know would love to hear about it.
Okay, we can talk about it. I don't know if there's time in Q&A, but I just wanted to say a few things about the experiences, and we can come back to that later if there's time. Okay? Because as I said, we have been using the library for quite a long time at our company, and we found out that it really works quite nicely, but only in situations, of course, where you have control over object instantiation. We have a special feature for ASP.NET, for example, so you can mix ASP.NET pages and controls. But if you don't have any control over instantiation, you simply can't use it. Second point, if you have an interface-oriented architecture, it's much, much easier. For example, if you use inversion of control stuff, it gets much easier to use, and you can have more type safety and more features at the same time. We have very good performance because, as I said, we are using reflection.emit to generate the subclasses. And the generated subclasses are just as fast as if they were handwritten. We only have a small delay at application startup time. And you can even nullify this delay by pre-generating the types, saving them to disk, sort of like Engine does just for Mixins. Debugging works really nicely too, because reflection.emit works nicely with the debugger. So you can step into into methods overridden by Mixins. You can step into the interface implementations provided by Mixins. Yeah. Last experience we've made, or the most important piece of advice we have found is use responsibly, because if you have a Mixin library for static languages on the .NET platform, it's very tempting to try and solve any problem that isn't single inheritance, or that isn't simple inheritance. Just use a Mixin to solve it. It's just there's a problem with the class, just use a Mixin to override a method and be done with it. Right? That's of course not the right way to do it. You should still have your design patterns catalog ready and so on. Okay, I'll just summarize the points I've made. Yeah, this library adds Mixins for static languages on the .NET platform. It's a great way to avoid code duplication. It's great for product line development, and it's also a great tool for general extensibility. It is quite simple to use, actually, because it has few features, but it's very powerful with these few features. And yeah, to conclude, the Mixins library is actually part of a larger enterprise application framework, which tries to take this extensibility approach to user interface layer and storage layer, as well as a domain level, the domain model layer. And the whole library is going to be released as open source under this domain. Actually, there's already a preview version of the Mixins library ready for download there. So if you want to check it out, you can just download it and take a look at the source code. So I think we have a few minutes for Q&A. No? Is that right? Yeah. So, if you want to say?
I just go back to one of our slides that tries to make the point
Implementation
of... No. Do you have a slide for that?
Yeah, there's just one.
Okay.
No.
No, okay.
Because I just wanted to
go to one of the
say that.
slides. I'll pick up the slide, you do the talking, okay?
Okay.
It's this one, right?
Yeah, that's actually all there is about implementation, because we don't do anything else besides just creating a subclass proxy the first time you create an instance of a class, of a mixed class using our object factory, right? We just use reflection of the mid to create a new class, which is derived from your original class, and which implements all the interfaces added by Mixins. And the interface is implemented just by delegating all the calls to the Mixin implementing the interface. And it overrides all the members and delegates to the Mixins, which declares the override. And that's actually all there is to implementation.
Quick question. I didn't pick this up from the discussion presentation. Yeah. Are you guys a code generator / compiler, or do you do all this at runtime when the code gets loaded?
We do it at runtime.
Through what facility?
Through reflection limit.
Yeah, but when do you generate these types?
The first time you create an instance of a mixed class using our factory. Yeah, we have a factory class, and you go by this factory and it does it. Because we can't intercept new, right? That's the main problem. Okay.
On one of your slides, you mentioned something about control of instantiations.
Yeah.
And like small suggestion, if you were to make this as a post build step, then you would have interception of the new commands, and you wouldn't have to use the factory.
That's right. However, we wouldn't have the possibility to add and remove mixins at runtime. At least not unless we instrumented all new calls in the whole application. Mm-hmm. And we wouldn't have the possibility to decide at deployment time what mixins we want to, unless we rebuild the application at deployment time.
Okay. And what happens if you have two mixins targeting the same function? So you would have some sort of junction, or?
Yeah. If they just add stuff, there's no problem. If they override stuff and conflict, then we have to define, there has to be an ordering in the base call hierarchy, right? And the Mixin library tries to guess the order, and if it's possible, it always guesses correctly, and if it's not possible, you have to specify it.
So they're linearized.
They are linearized, yeah, right.
Based on dependencies that they have in general. If they have no dependencies, you can tell them just configure.
Yeah. Okay, so that will be all. Thank you.
Thank you.